Warning! In this video we will be using high voltage. If you do not know what high voltage is and you do not know how to use it properly, please do not try anything you see at home. Okay, so what we have right now is we have our ATX here, ZVS with transformers here. We have the bottom frame, plate, whatever you want to call it, of our case, and we run into a problem. And you say, oh, what's the problem? Well, you know, there's a little problem. First of all, the ATX is grounded. The second of all, the negative of ATX is connected to ground, which leads into another problem. The negative goes through these wires onto the core windings, and we get a negative there, which is grounded. We hadn't had a problem yet that we had sparking here, but as a possibility that might happen. So we have to insulate it with a piece of acrylics so we can lift the whole ZVS and transformers up, insert the acrylics down and put it like that. We need about an inch, so yeah, we'll see how that goes, but realistically that should work. Alright guys, so we are continuing on with our power supply, and I got something excited. I was scratching my head and trying to figure out how to mount these electrodes so they do not short to the case, so they don't arc. And I was thinking, and I thought, okay, we have to put them up. How are we going to do it? So my first thing was, okay, I'm gonna take the enclosure, drill some holes in it, and I'm gonna mount my electrode in the middle so it has a good distance so it doesn't arc. Okay, it's not a bad plan at all. In fact, it's pretty good, but how are we going to do it? How is the question. So here is the thing. Take a piece of acrylics like this, you drill some circles out like that. Alright, then you take a tube like this and you cut some circles like that, and then what you end up with is your electrode being like that. Okay, you take your electrode, you put it in there, you tighten the screw on the back of your electrode. Okay, so this thing goes inside like that. Okay, and then the whole thing goes like that over the thing. Now check it out. Okay, so check it out. As you can see, we have a relatively big distance to our plate. Okay, so pretty much we can say it's safe to put the 50,000 volts on there, and still it will not arc to the case. Now, of course, that is only in theory. I'm only in prototyping stage for this design, but it seems to be pretty promising. Alright guys, so we changed things up again, and this time it's very good. Very good. So number one, we decreased the capacitance, so now we are getting higher voltage. Second of all, decrease the gauge of wire for the primary. This solved the problem of power supply switching off, so we don't overload the 12-volt rail anymore, because we get lots of heat here. So it's kind of not a win-win, but think of it this way: if we get more voltage and more power out, this is just nothing. If it burns, replace it. Anyway, the third thing is I found the problem where these cores would be arcing to each other. So what I had to do is I took a alligator clip wire thing and connected the two metal pieces there. So now it's not arcing anymore. The other thing is we got way more voltage. Way more voltage. I'm going to show you some footage somewhere on the screen. So essentially, we were able to boost it up to 60,000 volts approximately, and this thing is just crazy. I mean, it's just crazy. So once again, we will make sure everything is working, and I will experiment with different capacitance, obviously, to change the frequency, and we'd be able to get more current or more voltage. Also, we might be able to further increase the voltage with this capacitance being lower. I have to actually check that. But anyway, this is so exciting, and we are almost done. Alright guys, so we are at the final stage, really, of making this thing. So essentially what we have is the flybacks are now attached to the acrylics. We will desolder this guy and solder this high voltage cable. Now this high voltage cable is essentially a garden wire. Now what do I mean by a garden wire? Now this thing is used for holding the plant to a stick or something like that, right? So you take that, and by a coincidence, this is a very good insulator, this rubber. So you just use it as a high voltage cable. Now the rubber is very soft. This is probably why it's such a good insulator, but since it's very soft, it's easy to damage it by something. So you put some very good mesh on top of it, and green becomes red. Also, now it's protected from any physical damage, so pretty good cable. Handles 60,000 kV. Alright guys, so what we have now is we have almost everything is connected, and we are almost good to put the top on. Now what I'm doing is, remember I showed you these earlier? Now they're black color, and I used super glue to glue them. Doesn't really look nice, but we might paint it black. Okay, this is what it looks like in the end. Alright, with a electrode. Now these will go here like that and on top, and it should be awesome. Alright guys, so we are at the final stage of the project, getting some final touches here and there to make sure everything is working fine. So what we did from the previous update is we had fixed some problems and further improved the design. So first thing, we taped the hell out of the ATX connector. This thing was sparking constantly to my table, so I had to insulate it so it doesn't do that anymore. Same thing goes for other extra wires I had to chop off. The next thing we did is we had connected the dummy load with a thermal compound onto a heatsink. Now it's dissipating all of that heat to the heatsink. So now we are okay. And I might have a picture somewhere of a dummy wallet on the screen for you. So also what we did is we had desoldered our auxiliary on-off for our ZVS, and that is done because we had placed the switch for ease of assembly. So instead of making a square hole, I just drill a hole and put this switch in, and we're done. So this will replace the one I had before. By the way, this is the front plate of our power supply. Okay, very simple. LED for seeing if the power supply is in standby or on, and then this is on off for our ZVS. Pretty simple. The next thing we did is we used special rubber splicing tape to tape the hell out of our output cables. Yeah, the insulation just couldn't handle the voltage on the flyback there. This is the output cable of that flyback. It says 40 kV. Well, yeah, good enough until you get 60 through that cable. So when you hold it, the thing arcs to your arms, and the problem was when you're holding the switch, which has a positive here, so it would arc from there through the core, through the wires to the ZVS, and you get a big shock. So that's not fun. So I had to tape it so it doesn't do that anymore. Plus it will be in a metal enclosure, so we have to make sure it's properly insulated. Alright guys, I am very excited because the project is fully complete and I cannot wait to show you the final result. But before we can do any of that, I just want to show you the things we did that we have on the front panel, on top, and all of the electrodes, so I answer every question. So on the front panel we have our LED indication light, red for standby and then green for on. Okay, and this switch is for the power supply as well. So this is power supply only. This switch is for our ZVS, our auxiliary on off, which only controls the positive going to the gates of the MOSFET. So we are not switching any high currents here. We are only switching the gate. On top we have our electrically insulated electrodes, black for negative, red for positive. On the negative side we have a large aluminum disc to help attract the charge, and on the positive side we have a carbon electrode which is sharp tipped, very sharp. This helps to transfer the charge so it can penetrate the air. So now once we know all this, let's actually test it. Alright guys, this is it. We are connected to the mains power, and at the moment the ATX is off, but we will turn it on in a second. Before we turn it on, let me warn you. This is not a toy. This is intended only for high voltage experiments and should not be used in terms of entertainment. This is a power supply that is lethal. You know, you can play with 10,000 volts, not 80. I mean, this can not only burn your skin but potentially stop your heart if you're really not careful. So this is not a toy. Anyway, because we know what we're doing, we turn the power on and the red LED lights up. The next step is we turn it on and the fans turn on. So yeah, and we turn it on in 3, 2, 1. Now, as I said, this is not a toy, and you saw I stayed away from the actual outputs. Now, if you do not believe me that this is 80,000 volts, let me show you the gap distance. Alright guys, so as you can see, I had shorted out the power supply outputs, so we do not get a shock when measuring the distance, because we have a capacitor inside the flybacks and they do have a tendency to accumulate the charge over time when it's off. Anyway, what I'm going to do is I will show you the gap distance, and keep in mind the video is called 45 kV power supply. We might have to change it, but here we go. 8 centimeters. 8. Not 4.5, but 8. And then if you like inches, if you're a USA guy, there you go, 3 1/4. Alright guys, so what I did is I turned off the light so the spark is more visible, and as you can see, we have still our 8 centimeters gap distance. Alright, and I'm gonna turn on the power supply. Alright, and we hear the fans turn on now. I'm gonna, well, not really wording, the sound is very annoying from the spark, really high pitch and very loud. So if you are wearing your earphones, headphones, whatever you're wearing, keep in mind, turn the sound down. 3, 2, 1. Alright guys, so we are fully complete, and I showed you what this is capable of. Now, you know, obviously this is not a power supply you would use every day, but it's just great for those high voltage experiments. You can do the oil drop experiment and something like that. It's hard to control the voltage with this thing, but you can accommodate for that. Anyway, the next video probably will be about these high voltage capacitors out of these little glass cans. I will not go into how you make one, but I will do that in the next video. The next video will probably come out, if not this week, next week, because I still have to film this and actually figure out how to make the electrolyte, but it's coming out soon. Anyway, if you like the video, please leave a big like down there, and also don't forget to subscribe so you know when a new video comes out, and stay tuned for more content, and see you next time.